Uh, Logistic issues, please turn off audio mode. Only use audio mode. Please and follow up one to one. We can follow. So with that, let me go to my title slides. So the title of topic of today's webinar is ensuring successful and economical hydrocarbon production through life cycle application of flow assurance technology. And we will go a little bit deeper into this, into these words. What does it mean to be successful, economical, and life cycle, and finally, what's flow assurance technology? So before we go into that, my name is Syed Tariq, and I am Reservoir Production Director for 3DOS. Just to give you some background, I have a PhD in petroleum engineering from Stanford University. 42 years. Most of it is in ExxonMobil, but I also worked few years in Schlumberger. And I have worked all over. So my basic expertise in reservoir production engineering, enhanced oil recovery, and also lately flow assurance. This I have as my assignments with ExxonMobil in Qatar and Abu Dhabi. I as a production manager, I came across a lot of asphaltene issues and I handled them myself as a project manager. So I developed a certain expertise in flow assurance, which ExxonMobil thought was enough to be an instructor in this technology. So in this presentation about flow assurance. So next, just a brief outline of the presentation. So we will go through definition and importance of flow assurance. This is a new term being used in last 10 years, last couple of decades, and we will see what it means. Then we will go very briefly into flow assurance challenges and issues, and can be characterized into four areas: analysis, flow impedance, things that cause flow impedance in our system, and things loss of system integrity like corrosion, erosion, souring, etc. And finally, operability, operating strategy, and recovering from blockages. So as we go through this presentation, you will gradually get a sense of, what all these are and what is the importance of each of these. I'll also present in the end a case study of a flow assurance workflow that we did some years ago in a giant field. And finally, some comments on 3DOS capabilities. And then if you have questions and answer, we'll come to that. Okay, so this is the outline. So we start with definition. So flow assurance includes all issues important to maintaining the flow of oil and gas from reservoir to host facilities through life cycle of an asset. So if you have to write a sentence to define flow assurance, that's what it is. It's all issues that ensure that we will maintain the flow of oil and gas from the reservoir of economic life of an asset. In the original reservoir state, the hydrocarbon and whatever is in their rocks and formation water have been in equilibrium with its environment for millions of years, for geological time. So if we don't disturb it, they are in equilibrium. During production, we disturb this equilibrium and disturb it rather abruptly. And so as the hydrocarbons and water and come out of the reservoir to the production system, the fluid tries to reach a new equilibrium. And in doing that, in the changing environment. So in doing that, there are phase changes which occurs. For example, gas breaking out from oil, liquid hydrocarbon condensing from gas. But more importantly for flow assurance, it's the solids that form as the equilibrium is broken. And these solids sometimes are very nasty and they can stop your production. So these issues are very important, and flow assurance is about understanding these threats and developing the appropriate engineering, design, and remediation method to combat these threats. The term flow assurance is a rather new term in petroleum industry. It was introduced by Petrobras in early 90s, because they had an experience when they went to deep water development. They spend in a number of cases they spend billions of dollars to develop the facilities and all that. Solid reasons and flow assurance reasons, they could not maintain the production. So within 6 months they had to halt their production. So that's when they coined this term, that we need to systematically go and guarantee the flow before we develop anything. And so that's where the flow assurance comes in. The high capital cost and the restricted accessibility of deep water facilities and flow lines made it critical to understand them. And with the move to increase such as Sakhalin and Alaska, in these environment and temperatures, the flow assurance issues have become very, very important. So so the best strategy for flow assurance issues is to prevent them. So just take care of it during the design phase, during very early phase, so that don't happen once they have happened. So for example, here in this slide, I'm showing some of the flow assurance challenges that happen, what type of things can happen, and we will go through some on some of these in some detail. This is a vast subject. Flow assurance is a vast subject, and we can to really cover it properly. You need a 5-day kind of complete course. But I'm just giving you an overview to give you a feel for what can happen. We have these well bores, and in the well bore, we can have asphaltene, we can have sands, and then as they flow into the production platform, in the platform, you can have slugging, you can have emulsion, you can have wax, your fluid can foam, and all this cause impediment to flow. And then during the transfer from the production platform to the FPSO in the transfer line, you can see here you can have wax, hydrate, corrosion, slugging. These flow lines are sometimes very long and they are at low temperature. at the mud line. So it can be a problem. And anytime you are injecting water and mixing two incompatible waters, you can have a scale issue. So these are the type of problems that, any one of them, if not taken care of properly and systematically, can kill your production and, cause a shutdown which can last for months. So lost production. So next, of these flow assurance challenges. So if you have to take care of these, what do you need to do? So we need to design, for example, starting from the reservoir, you need to design proper tubing side. You need to insulate it. In some cases, depending on the threats that you have, that I showed in the earlier slide, you may end up doing one or the other of these things. You know, at the flowing, at the production platform, you should have provision for receiving slug. You should have provision for heating, chemical storage, injection water treatment if you want to avoid scaling. And you can, in some cases, you are required to have insulation in the flow line. You can have gas. You may be required to have a gas, and you may have to provide heating capability for storage. So, and in some of these flow lines, you may have pigging. You may have to provide pigging capability. So these are all provisions that you may need to provide depending on the challenges that you have. So this is systematically you have to, and sometimes they are not obvious. So yes, I'm working on a field in Pakistan right now, Adi field, where they have been produced. It's a 203 million, 300 million barrel field, and right now their production is just in danger of being shut down because of asphaltene. And they have produced for 10 years, but they never realized that they will have this problem, during the mid-life cycle of their field. So sometimes this problem is not obvious. Once they happen, then it's very expensive, if nothing else, for the lost production. So what is the scope of flow assurance? What do we do in flow assurance activities? So the key to handling any flow assurance issue is fluid behavior and properties. So that's the key. And because most of these issues are occurring because the fluid is going in disequilibrium and then precipitating things and depositing things. So we have to understand very well what the fluid behavior and properties. So production chemistry as a subject is very important that we need to bring in flow assurance. The other subject is the fluid flow in wells, flow lines, risers, umbilical tubes, export pipelines, etc. So we need to analyze fluid flow and multi-phase flow. Techniques. So, the impediment to flow can happen due to blockages, due to solid deposition, hydrates, paraffins, asphaltene, scale, sand, precipitants, due to you can your flow can be affected by liquid slugs and surges, emulsions, foaming, loss of system integrity, corrosion, erosion, reservoir souring, and then finally operability and assurance scope. So you can see the flow assurance issues are not only for the design purposes in the beginning, for your development, for your developing your system, but it's also throughout the operations. You need to make sure that you can operate the system. So this is the scope of flow assurance activities. So going to next slide. So what is the technologies? What are the technologies and science that we bring to solve flow assurance issues? So the first is the hydraulic analysis. So we need to study this, and sometimes in the deep sea systems, fluid flow in the risers, you know, to understand what's happening there. Combined with hydraulic, we need to also study this system for thermal analysis. What are the system temperatures, whether we need insulation or active heating requirements, because to prevent some of these solids to come out and deposit, we need to keep a minimum temperature. We need operability investigations, warm up, cool down, blow down. These are the things that we do in do during the operations, slugging, and define strategies on how to implement it. Investigation of potential for blockages. So these solid deposits that can form, and I'm sure everybody has heard of hydrate, wax, asphaltene, scale, sand, and there are a bunch of other naphthenics. Chemistry comes in. We need to study PVT in a lot of detail, and rheology studies, phase behavior, non-Newtonian behavior, because wax, for example, when it deposits, and before it deposits, it's kind of a non-Newtonian fluids and it flows. Emulsion characteristics, biodegradation, all. And then mechanical integrity, system damage due to corrosion, erosion, reliability, and availability. So you can see this flow assurance is essentially a multidisciplinary subject. So you need to have a good idea of all this. You don't need to be an expert in all of this, but you need to know what are the parameters, what can happen, what cannot happen. So you need quite a bit of experience to handle this flow assurance issue. It's not one dimensional. It's just. So next, and flow assurance also interfaces with almost everything. It interfaces with reservoir, topsides, risers, flow lines, production lines. In big companies, flow assurance is handled in research departments, marine exploration and operations, and well completion. So you can see, the interface. Flow assurance is an issue for the complete system, complete oil production system, hydrocarbon production system. So it has to be handled in a systems manner. So integration of system is very important. So I'm giving you this some general ideas about flow assurance, and then I'll handle I'll come to a couple of solids that are commonly, and then I'll give you a case studies as to workflow. What do we do when we are faced with a flow assurance problem? So some of the consideration is for flow assurance is flow assurance must consider capabilities and requirements of all parts of the system. So all parts of the system, you cannot, you have to start from reservoir and go through the whole system till you store the produced fluids and kind of transport it outside. And so if you leave any part of the system a weakness, that may be the thing that becomes your weakest link. And you have to consider the entire producing life of the system. This is very important, and I have seen in flow assurance studies that people tend not to consider entire production life. They just consider what will happen in the beginning. So fine, that's in the beginning your flow rates will be high, and so things may be okay. But once your flow rates production drops to a certain level, so there are certain flow rates like wax. Wax is deposited only at relatively low later in the life. There are reservoir characteristics. You have to see what your production profile is throughout the life for 30 years, 20 years, 30 years, whatever you are designing your system for, and whatever flow streams you have production profile for 30 years. You have to we have to bring in fluid properties and behavior. System design, it has to be handled in a systems way. Operating strategies is very important. So the system in a certain way, or we fail to operate it in a certain way. So, and other system variables. So flow assurance, a systematic flow assurance study gives, if there is a new development, if it gives lots of input for the design of the system. Okay, so it kind of for example, here I have listed few things like flow diameters of tubing and flow lines, maximum and minimum production flow rates that you can target. Insulation, whether you need to insulate any tubing, flow lines, wellheads, trees, and manifold. Chemical injection and storage requirements. So this is all an input to the design of facilities, production platform, or on onshore facilities. Flow blockage intervention needs. So it's very important. And take, so in the system design, you have to accommodate what will be needed if there is a blockage is to happen. Host facilities requirement, flow receivers, fluid handling, pigging, blockage prevention, intervention. So all this for the host facility, you have to get. It gives you a lot of a systematic flow assurance study gives you parameters for your system design. What should be in your system? But then, on the other hand, it also puts some parameters on you can assure that system can be built and operated successfully and economically. So principles are set at the beginning of the system design, and that leads to operating strategies, and then the operating strategies eventually lead to actual operating procedures and manuals. So flow assurance study has to develop a robust operating strategy and procedures, consider unknown and uncertainties, all production modes, startup, steady state, rate change, and shut-in. there have been a number of cases where in the there are specific issues, then a steady state. If you change a rate, sometimes this flow assurance challenges are kick operations of your system. In fact, there have been cases where a field was producing fine for a long time, and then they shut in and then could not bring it back easily. It took them 6 months to 1 year to bring them back. This is because flow assurance issues. So this is about the flow assurance. Next, I want to just to give you a feel for what some of these solids are. So there are 6 solids that occur in hydrocarbon systems, and these are hydrate, wax, asphaltene, scale, diamonds. So I have taken 3 of them, which are which I have dealt with quite extensively in North Field, Qatar, and hydrate was a big issue when I was there, and so we had a project handling hydrates. So that's where I developed my expertise. So hydrate, just to give you a feel for what it is they are crystalline. They are crystal cage, and these is what organic molecule. So, for example, here is shown that a cage of water molecules have captured a C1, the methane. So methane. So, and there are various structure of these molecules and structure, and not only methane, but hydrates can, a lot of people don't realize hydrate can also happen in not only in gas, they can also happen in oil. So, sometimes these organic compounds that are captured, not C1, it can be C4, C5, C7, under certain circumstances. So the requirement for hydrate formation is there has to be water, because you need, you need water molecules for the cages. So these are hydrocarbons, C1, C2, C3, or whatever. And then you have to have an appropriate temperature. You have to have low temperature and high pressure. So hydrates tend to form at low temperature and high pressure. And if you look at hydrate, they just look like ice. But the only difference is this ice, if you light with a match, it starts burning, as is shown on the right. So hydrates is a common problem in oil industry, and all systems, especially the gas producing problem. But it is a common problem. So what is impact of hydrate if it happens? Is there is a potential for wellbore, flow line, and complete blockage of your flow line. Complete blockage means your production goes to zero. And process, it takes weeks to months, and you have to shut it in your clay, it doesn't easily melt like ice. So, you have to give it time, you have to heat it. And so normally if you let a hydrate blockage happen, it's kind of economically, it's a death blow to to a system. Uh, so the best strategy is not to let it happen. I suspect that in your design phase, you have to have you need to take care of it in precision. So you need to have a concept whether you want to have separate uh, or full your flow streams, and have it only a dry pipeline or a wet pipeline. You need to consider insulation requirement, chemical lines. So hydrate can be prevented by injection of chemicals. So you need to provide for chemical lines, injection points, storage, pumping capacity. You need to also be ready for the operational procedure in case hydrate blockages are formed. Provide all that to handle your hydrate problem. Three type of things you can do. One is thermal. So if you insulate your system and don't let the temperature, if you see here, this is pressure, temperature for a certain fluid, and this is the region where hydrates are formed. So they are formed at high pressure, relatively high pressure and low temperature, and they are not formed if the temperature is higher than a certain threshold value. So your idea is to not operate, never operate in this region. Even when you shut down, you have to do something that you will go to higher pressure, but you should do something so that your temperature will not come in this region. So that the operating envelope becomes much higher. So thermal methods, insulation or active heating. Chemical, you can inject thermodynamic inhibitor, and they are a couple of kinds. Pressure, you have to operate at lower pressure, and depressurization during your shutdown, you need to have a provision for depressurization. Composition, you can also prevent hydrate if you just dehydrate. If water is not available, hydrate will not form. So this in a nutshell is hydrate formation. So that's one solid. The second solid that I will that probably everybody has heard of is wax. So we have waxy crude, which have long chains of N paraffins, and they can be defined in a certain way. So their scientific definition is hydrocarbons, insoluble in water but soluble in most organic solvents. The field definition, so that's a scientific definition. That's something for people in the research lab. The field definition is hard or sludgy stuff found in pipelines that looks or feel waxy. So this is for operators, these people who in the field, that's the waxes. And sometimes what they say it's wax is actually can be a combination of things. It can be, it may have asphaltene in it. It may have a scale in it. So anything that becomes kind of a sludgy stuff and in the pipelines and looks kind of the practical definition for upstream. So for the definition for from oils composed of in your composition. If you have high molecular weight and long, they are very sensitive to temperature C20, normal C20 molecules. And this is how wax looks like. And in the field for operators, this is like wax looks like. So this is a pig that has come out of a pipeline which had wax deposits in it. So wax deposition is strong to insulate your system so that you don't deposition requires outward heat flux even if the oil is below uh, a temperature below which wax tends to appear. Wax deposition is a slow process, so it does not happen very quickly. It only happens over a period of time in the pipeline. In a long pipeline, it only happens after flow has flowed, for a distance. Sometimes after miles of flow, then it starts happening. And deposition rate is interested in the subject. So the deposition rate is very slow. It's less than 2 millimeter per day. It also changes its characteristic. It kind of hardens over time. So fresh wax deposit are a non-compact collection of crystals. So fresh wax deposit actually have a lot of greater than 90. The porosity of that decreases erosion, and hardness increases much more rapidly. We have made the bottom line is that wax can appear in many forms. It can be hard wax, it can be pasty, it can be soft wax, and it can be in the form of a gel. So there are wax system of your fluid that is flowing. So your delta P, you have to give more power. Eventually it becomes like it gels and it can completely block the flow. In this pipe, this is the wax deposition. So what an impact it has had to reduce the diameter of your flow stream. So how do we manage wax in a system? So this is a topic for flow assurance. So again, there are three methods. There are chemical methods, there are thermal methods. When we deal with solids, these are the three things that you can do to prevent them and the best thing in any flow assurance issue is to prevent it. Prevention is better than cure. If you prevent hydrate, it's much easier. It will be much more economical than similarly for all low assurance solids. So you can see there are chemical methods, thermal methods, and mechanical methods. Mechanical methods normally used as pigging. So with a certain frequency of pigging, if because wax deposition is a slow process, you will not have wax problem. So you may just want to solve your wax problem by a certain pigging program. You can also insulate your pipelines, and so you prevent outflow of heat. So green are the one that are most commonly used: insulation and pigging. And if you end up having a deposition which is problematic, then you have to go to some of these things, which is yellow. And these techniques, coating, some people have proposed that if we coat our flow lines, wax will not deposit. These are not proven. And similarly, some chemicals are not proven. So this is wax. So the typical wax management strategies, you have to certain temperature. You should have capability to pig. You have a capability to inject chemicals, and you should have coil tubing access. So next is solid is I'm going to cover is asphaltene. And asphaltene is I have worked in asphaltene in Upper Zakum field, which is a very huge offshore field, 60 million barrels. And when we started injecting miscible gas in it, we had a big asphaltene problem. In fact, the wells were, it was so obnoxious that we had to shut down some of the wells. So asphaltenes are very high molecular weight polyaromatic compounds, which are, there's a chemical definition. They are not soluble in N-pentane and N-hexane, but they are soluble in higher aromatic compounds. They are most likely to precipitate at reservoir as fluid is depressurized towards bubble point, or a saturated compounds are added to liquid phase. So there are two ways asphaltene can be in your oil and cause no problem. And in fact, it's the issue of asphaltene has nothing to do with the amount of asphaltene that is present in the oil. In heavy oil, sometimes the asphaltene is up to 9 to 10%, but never causes a problem because there are also solvent. And you mix, you either decrease the pressure or you bring some other lighter fluid and mix it with your oil. And they usually deposit in near wellbore formation, well correlated with content. So I already said that. So I'm currently working, as I think I told you earlier, I'm currently working on an asphaltene problem actively for a field in Pakistan, Adi field, which has this problem. And this problem was there and they could have actually detected at the early stages, but they didn't. They kept producing, and now they are at a stage where they have to change their filters in the surface facilities every 3 hours to maintain their production, and it's getting worse. So they want to know what needs to be done. So there are certain specific certain measurement that we do for asphaltene screening. And you probably heard of slot. And fluid testing is a must. fluid is the key to any flow assurance problem. If you haven't characterized your fluid, you haven't collected good sample under in situ condition and have not analyzed them properly, then you are not set at a later stage to analyze. You can only do remediation, mitigation, but you cannot prevent it probably. So here in this plot, do De Boer's plot. Very simply, you can take your composition and characteristic of your your reservoir pressure and bubble point pressure and density, and you can screen. If you are here, there will be severe problem. If you are here, there will be no problem. So asphaltene management, the prevention is the key for asphaltene management. So you need to watch out your producing condition, rate, pressure, temperature, GOR, and don't mix. Don't mix two incompatible fluid, because asphaltene then are destabilized and come out of the solution. Remediation, it can be dissolved slowly using solvent treatment, xylene, and these are just details of the treatment. You can also mechanically mill or scrape, or jetting is required. It's difficult to remove. It's difficult if it happens. So the emphasis is on prevention. Okay, the final solid that you probably all of you have, if you have worked in the oil field, is the scale. The scale is just any hard inorganic mineral constituent of water that can potentially accumulate on a surface in contact with water. So this normally happens when you bring two incompatible water. You inject seawater with lot of sulfate in it, and your formation water, it mixes with formation water, and then these things precipitate. And some of these just so hard. Strontium sulfate, for example, is a type of scale that's so difficult to. Once it happens, you really have to take your tubulars out. Nothing you can do. So this is another flow assurance. So we have not gone into detail of any of this. So I just wanted to give you, for some of you who have not dealt with these issues before, just want solids. You have to have a detailed workflow to understand and then go and solve it. So finally, so I have given you it so far in this webinar, the definition, of solids which bother us in oil field production. And finally, I just go, and it's an old case, so I'm I just want to show you. Don't go and look at the details of this, but see what how it's done. What are the steps that we take to kind of make flow assurance for a project. So we have a we have a large field, a very huge sequence of 13 M series, K60, K70. These are different zones, and they have different type of fluids. So you have in this column of in this sequence of reservoirs, you find all kind of you have lean gas in T13, you have M series zone, you have near critical fluid, you have K60 gas condensate, K70 oil. So, and the wax deposition tendencies in the lean gas is none. If you have lean gas, the wax gas condensate again is low, it's not there, and oil, it can be high. So there is a range of wax deposition tendency. So originally this flow assurance issue. But you will see that when when we did all this analysis, we came up with a lot of other things. So this was you can see a range of wax deposition tendencies. There is low in gas condense, none to in lean gas, to high in oil, and near critical fluid. The other thing is there's relatively low reservoir temperature in all of these cases. So K60, for example, can be up to 115 degrees F, 115 degrees F. So this is low reservoir temperature. So it's prone to deposition of wax and also hydrate maybe. So the first issue is, the reason this study was commissioned was to find out whether they need to, because they will be producing from all these zones, whether we should segregate fluids in clean and dirty flow lines, or we should flow all of this in one flow line. So, that was the key question. Clean means, flow all the fluids which have no wax or hydrate tendency in one flow line, and then dirty flow lines you have separate and flow in that. So this was the problem. So the first step in any flow assurance issue is to do sampling and measurements. So the key to flow assurance is a good characterization of your fluids in your system. And the good characterization will come only if you have taken done PVT analysis. Well, PVT analysis is done normally for to create a reservoir equation of state for reservoir simulation and all that. But for flow assurance, you have to go beyond that in the compositional analysis. You have to do extended composition. And then there were a lot of tests, specifically pore point, cloud point, asphaltene content, sulfur content. So all these tests were specified. But you can note that they were conducted only at only 2 wells. All of these tests were conducted on 2 wells, and for other for two types of fluids, for two zones, sorry, 2 zones, not wells, 2 zones, and for other, a subset of this was done, because they were considered to represent, for example, K70 results were kind of considered to come to represent also K60, and M50 results were considered to represent M30 and M10. So for a certain key wells, a very detailed analysis was done. I think I'm running out of time, so I need to accelerate it. So this is, for example, for wax. We have high concentration of N-paraffin, high molecular weight N-paraffins. If you see here, NC20 plus 2.40, 2.15. So these are the oils which have high N-paraffins. So they are prone to wax, and this of right here is of heavy molecular weight N-paraffins. So low propane K60 is proven to be not a wax vulnerable zone. Okay, and the others are. So with this type of analysis, I don't want to take you. There's too much detail here. If we have a course for 5 days, I can probably go into detail of each of this and work it out. To tell people what's happening. So then, once we have the measurements, and we went to lab and we did some insulation work, insulation testing, and we figured out that if you do good insulation in your pipes, then your deposition of wax will take a long time. So you can see this time, this is a log scale. So 1 day, 10 day, 100 days, 10,000, 1,000 days, 100 days. So as you decrease this insulation, you're very slow and will happen at a very long time. And similarly, we do modeling. So after we do these experiments, then there are some very specific software called wax deposition model. And then they are compared with the experimental results from the lab. Okay. So after all that, you can see, certain suggestions were made that your pipeline should, be wax appearance temperature at this point. So you can have a line up to 20 miles. After that, we will have wax issue. So these kind of things were kind of established. So next, we also consider, this study was commissioned for wax, but when we start looking at hydrate, we found that under shut-in conditions, you will be here. Under shut-in conditions, and which is way inside the the hydrate envelope. So this is the hydrate envelope. So you need to do something so that these points do not remain here, they come here somewhere, or you don't bring the pressure so high. So these are the design, or you design a system to inhibit for shut-in conditions. So when you start shutting in, before that you start inhibiting, and you can also consider what hydrate was also issued. Again, same fluid characterization, sampling, measurement, lab tests, and then modeling. And asphaltene, in this case, the asphaltene plot showed that all our fluids were in a, in the region where asphaltene is not expected. So asphaltene was not an issue. Slugging. So this is a, slugging can be another issue in a subsea environment. So this is your riser, and this is your subsea completion, wellhead is, well is, and this is your terrain, the sea depth. So this was modeled to see if there will be a big slugging problem. And finally, after this study was suggested that provide a slug volume of 50 barrels in primary separator for normal operations. So no need for big slug catcher and all that. So, as a part of the issue, we consider other issues like corrosion. So this was a comprehensive flow assurance study, and created a lot of successful design parameters and operability. And this is summary of everything that was concluded. So you can see it was concluded that paraffin impact is high, hydrate impact is high, asphaltene impact medium, sand erosion medium, scale low, low, end of a flow assurance, a successful flow assurance project. So now, having said all this, as you can see, it's a multidisciplinary, any flow assurance project is a multidisciplinary project. It involves a lot of skill set, which not one person one person can know it on the surface, with a lot of experience, 40 plus years experience, you have exposed to almost everything. But, it really requires a lot of interdisciplinary work to do a successful flow assurance. And so now come to 3DOS. We have some very, very experienced professionals in our team, and we have 300 plus years of combined experience. Sondo, myself, Kui, we are all, handle this production and capability of flow assurance. So if a flow assurance project is there, we can handle it. And we have global experience. So, we have experience in Alaska. I have experience in Qatar and Abu Dhabi. I have experience in Chad here, very close to. So we bring this global experience, and we bring everything together for the local solution. So final thoughts. So before you leave and after you are in, maybe you are not, you can think about it. You can impress your boss by saying, have we looked at this current and in future? Means, as I said earlier, the flow rates are low, then they start happening. I'm dealing one of these problem now in a 300 million barrel field. Would you like for us from 3DOS in any way? Let us know. We are here to help you. We can provide training, consultancy, project management for flow assurance. Now we don't have that is needed to perform some of the flow assurance work. We don't have that. But what we can do is, we can go to third parties and we can manage it. We can actually keep all those people honest when they are doing the flow assurance project. If you'd like to have one-to-one session with our experts, let us know. With that, thank you very much for your time. And I hope, I was able to convey a good overview of flow assurance. Thank you very much. Any questions? Can you hear me? Hello?